and then we move to the new topic. Okay.
Sir, last time we discussed covalent compounds and we
Hmm.
had a short test.
Hmm. Yes, here we have O-level chemistry, here we lectures. I think this is, no. Yes. So last time we have completed these structures, right?
Yes, sir. We did the three structures of
Okay.
graphite, diamond,
Hmm.
and silicon.
Yes. Now this is our topic. Describe the giant covalent structure of graphite, diamond, and silicon dioxide, right? Yesterday, we have done this, right? So I am not satisfied from the yesterday class, right? That's why I would like to repeat the whole chapter again. Okay, are you with me?
Yes, sir.
Okay, so you may satisfied, but I am not satisfied. That's why I will do it again. So can you tell me what is graphite and what is diamond? Yes,
Graphite, a rock.
graphite and diamond both are
Yes.
allotropic form of carbon, right?
What does allotropic mean?
Allotropic. Okay, now listen, what are allotropes? So let's suppose this is graphite. This is graphite. Graphite just like coal. And let's suppose this is diamond. So properties of graphite and diamond both are same as carbon, right? So both are allotropic form of carbon. But the question is that their physical appearance are different, right? So allotropes are those elements which are physically different, but chemically they are same. Are you getting my point or not?
Yes, sir.
Now, first make the heading graphite and diamond. Graphite and diamond. Graphite and diamond.
Sir, lecture number 9 here.
Sorry,
Lecture number 9.
reaction number 9.
No, sir. Lecture number 9.
Yes, this is lecture number 9. Sorry, this is
Okay.
lecture number 9. This is lecture number 8. This is lecture number 9. Lecture 9. This is lecture 9. So graphite and diamond. So first point, both are allotrope of carbon. Both are allotrope of carbon. Point number two. Allotrope are different form of element. Are different form of same element having same chemical reaction but different physical properties. For example,
Sir, isn't it the other way around?
sorry,
Same physical properties but different chemical reactions.
same chemical reaction but different physical properties. Different
Yeah.
physical properties means their color is different. They have different appearances, right?
Yes, sir.
They give different smell, right? But they give same chemical reaction. So such
Sir,
form is called allotropic forms, right?
yes, sir.
Yes.
Can you tell what is reading here? Allotrope are different form of.
Different form of same.
Okay.
Different form of same element having same chemical reaction or chemical properties but different physical properties. Now next, first heading is graphite and diamond, right? Graphite and diamond. Now first is graphite. First is graphite. Now look at the structure of graphite first, right? This is hexagonal structure. This is hexagonal structure, right?
Yes, sir.
Here we have carbon atom. This dot indicates carbon atom. This dot indicate carbon atom. So we have many layers, right? This is graphite. Now I am making graphite. All are carbon atoms, right? This is graphite, right? This is graphite. You can see that they are hexagonal in shape. This is graphite. 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 Hexagonal structure, right? This is structure of graphite. These are atoms in a layer. Atom in a layer. Atoms in a layer. Atoms in a layer. Look at the another structure of graphite, right? Another structure of graphite. So this is one layer, right? Atom in a layer. So this is one layer, right? Now I am showing atoms in two layers. Atoms in two layers. This is one layer, one hexagonal structure of graphite. These dot indicate carbon. Dot means carbon. Dot means carbon. Dot means carbon. So this one is graphite. This one is graphite. Consider another one. This is single layer of graphite, right? This is single layer of graphite. These are carbon atoms. Carbon atoms.
Sir, so graphite is made of carbon?
Yes, as I told you that graphite and diamonds are allotropic form of carbon.
Okay, sir.
Now look at this is one layer and this is another layer, right? So just tell me what.
No, sir. Listen.
Now listen. This is attracted by this one. And this one is attracted by this one. This one is attracted by this one. This one is also attracted by this one. This one is also attracted by this one. This is force of attraction, right? Carbon is attracted by another carbon. This is called van der Waals. So this one is two layers, right? Two layers. Atoms in two layers. Atoms in two layers. Atoms in two layers. Bete, are you getting my point or not?
Yes, sir.
So first point is that's now it is totally different from yesterday class, right? I am not satisfied. That's why I started again, right? So what is graphite? Graphite has a layer structure. Graphite has a layer structure. Graphite has a layer structure. Number two, it has hexagonal structure. It has hexagonal structure. It has hexagonal structure. Can you tell me what is hexagonal structure?
Sir, it's a structure which has 6 carbon atoms and makes one like a hexagonal shape.
Sorry?
Sir, it has 6 carbon atoms, so it has like
Yes,
an
yes.
it shapes like an hexagonal shape. It takes an yeah, it takes a hexagonal shape, hexagonal shape.
You are right. Now, next point is point number 3. Graphite is sublime. Can anyone define what is sublime? Or
Sir, like
graphite sublime?
it changes state from like solid to gas.
Exactly. It means, let's suppose this is C. C means carbon. C graphite solid. So when you heat, it convert into C gas. C gas. So graphite sublime. When you heat, it directly convert into gas. Are you getting my point?
Yes, sir.
Yes, sir.
Okay. So it convert into graphite solid to graphite gas. Now, next point is graphite has giant structure. Graphite has giant structure because it has covalent bonding throughout the structure. Throughout the structure. This is covalent bonding, right? This is covalent bonding. Now you can see that everywhere is
Sir,
covalent bonding.
between
Yes.
carbon and carbon, right?
Yes,
Covalent
between
bonding
carbon
between
and
carbon
carbon.
and carbon.
Yes, yes. Throughout the structure, between carbon and there is no other element except carbon. There is no element except carbon. Are you getting my point or not?
Yes, sir. But then, so all giant structures have covalent bonding?
Yes, covalent bonding. Except if you have ionic bonding, it is called giant ionic bonding. If you have covalent bonding, so it is called giant covalent bonding. Sodium chloride has giant ionic bonding, right? Now, number 5, you can see that there are two types of bonding. There are two types of bonding. There are two types of bonding in diamond. In diamond. This is covalent. And this one is van der Waal. So van der Waal is only attraction between two elements. This is called van der Waal. This is called van der Waal. There are two types of bonding in diamond. In graphite, right? What are they? Covalent, B. van der Waal. Van der Waal. Weak van der Waal. Between carbon and carbon,
So what's
between
the spelling
carbon
of
and,
the B?
sorry,
What's the spelling of the second type of bonding?
van der Waal, VANDERWAAL.
Okay.
So between carbon and carbon, covalent, bonding. Between layers of graphite, weak van der Waal. Weak van der Waal. Weak van der Waal. Are you getting my point or not?
Yes, sir.
Can you tell me how many valence electrons are there in carbon? Can anyone tell me the number of valence electron in carbon?
Sir, 4.
4, sir.
Four. Very good. So point number 6. Carbon has 4 valence electron. Carbon has 6 or 4?
Sir, 4.
4. Carbon has 4 valence electron. Carbon has 4 valence electron. Now, it means it can form how many bonds? Yes,
4.
4 bonds. So it can form 4 bonds. Now you can see it can form 4 bonds. So it can form 4 bonds. But
Sir,
here,
bonds between.
between carbon and carbon, you know that here we have only carbon. There is no
Okay.
other element. But can you tell me how many bonds are made by carbon instead of the 4? Yes. Can anyone tell me how many bonds are formed by each carbon?
4, right?
Yes, it can make 4 bonds, right? My question is that in the diagram, can you tell me how many bonds are formed here?
Oh, 3.
3 bonds. 1, 2, 3. So 3 bonds.
Hmm. Hmm.
So how many electrons are left in it?
1 more.
1. So 1 electron is left in each carbon atom. These electrons are called delocalized electron. Because of this delocalized electron, graphite conduct electricity. Are you getting my point or not?
Sir, so graphite has pairs of 3.
No, I told you that each carbon atom has 4 valence electron. So 4 valence electron means it can form 4 bonds, right? But in the diagram, you can see that each carbon atom form. Now you can see that 3, right? 3. Now you can see it here. 3 bonds, 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 3 bonds. So 1 electron is left. So this electron is left. This electron is called delocalized electron. So here we have electron, here we have electron, here we have electron, here we have electron, we have electron, here we have electron, here we have electron. So this electron is called delocalized electron. Delocalized electron. Because it is free. It is not encased to form any bond. Are you getting my point?
Yes, sir.
So each carbon atom has 4 valence electron. It can form 4 bonds, right? So number 7. In graphite, each carbon atom uses 3 valence electron. 3 valence electrons to form covalent bonding. To form covalent bonding. Covalent bonding. How many electrons are left?
One more, sir.
One more. So remaining 1 electron, remaining electron is called delocalized electron. Delocalized electron. Delocalized electron. And move freely. That's why graphite, that's why graphite is good conductor. Yes. Are you getting this point?
Yes, sir.
Now next is, that's why graphite is a good conductor, right? So next is why graphite is very slippery. Next is graphite is slippery. Can you tell me why graphite is slippery? Yes, why graphite is slippery? You know that in the pencil you have graphite lid, right? So you can write through by the help of the graphite pencil, right? So the question is that why graphite is slippery? Yes. Any answer? Hello, beta. Are you listening my voice?
Yes, sir. Sir, I don't know.
Okay. You know that graphite has a layer, right? Graphite is layer structure. Graphite
Yes,
is
yes,
layer
sir.
structure, right? So this is graphite layer. This is another graphite layer. This is another graphite layer. So when you drag, when you apply a small force, when you drag this layer, or apply small force, or apply small force. So the shape is totally changed. Layer move forward. Now this layer move forward. That's why graphite is so brittle. Are you getting my point or not? Layer
So,
one
sir,
is layer
sir,
one moved. Yes.
so basically because it's layered, that's why when you apply force, then the layer moves.
Yes, layer move. That's why it is very soft. You can write by the graphite. So this is because of the weak forces. This is van der Waal. This is van der Waal. So when you drag, you overcome the van der Waal. That's why it moves.
So that's why Van der Waal is weak.
That's why you know that van der Waal is weak. Now the question is
Yes.
that why they move? Why the layer move? Because of the weak van der Waal.
Okay.
Okay, write the next point for it. Covalent bonding within a layer are very strong, right? So the force of attraction between each layer is weak. The force of attraction between each layer is weak. The force of attraction between each layer is weak. We can easily overcome this intermolecular force of attraction. Intermolecular force of attraction. Force of attraction. That's why graphite is slippery or ductile or brittle. Yes, any question regarding graphite brittleness?
No, sir.
Okay. Next is,
Sir, can you go up?
sorry,
Wait, I'm copying the notes. 1 second.
I am unable to hear your voice. I need headphone.
Sir, sorry, my mic is muted.
Yes, can you repeat your question?
Yes, sir. I was copying the notes.
Okay, okay, just write.
Yes, sir. Done.
Okay. Now next property is solubility. Mm, So melting point first, right? It is very important. Melting point. Mhm. So melting point. So melting point. So first point is, you know that in graphite we have strong covalent bonding. So a lot of energy is required to overcome this, to break this covalent bonding. So a lot of energy is required to break this covalent bonding. That's why graphite has high melting point. Can anyone repeat my statement?
Sir, graphite has a high melting point because a lot of covalent bond is there. So it takes
Mhm.
a lot of energy for the bonds to break.
Mhm.
So that is why it has high melting point.
Very good, very good. Melting point is high because graphite has strong covalent bonds which require a large amount of energy to break. Melting point is high because graphite has strong covalent bonds which require a large amount of energy to break. Now next is solubility.
Sir,
Yes.
so graphite meaning it has a lot of covalent bonds. Yeah.
Yes, you know that throughout the structure we have many covalent bonds, right? These are,
Okay.
these black lines indicate this. This is covalent bond. This is covalent bond. This is covalent bond, covalent bond, covalent bond, covalent bond, covalent bond. So a lot of energy is required to overcome this, to break this covalent bond. That's why graphite has high melting point. Now next is solubility. Solubility. Now, can you tell me graphite? Graphite means coal, right? Is it soluble in water or not?
No, sir.
Very good. It is insoluble in water. Graphite is graphite is insoluble in water, insoluble in water, insoluble in water, and organic solvent.
Sir, what is
Organic
organic solvent?
organic solvent means ethanol in which we have carbon. Ethanol, methanol, right? So we will discuss organic chemistry later, right? It organic solvent. Are you getting my point or not?
Yes, sir.
Okay. So You know that what is allotrope, right? Mm, okay, this is, I think, enough. Now you can see the shape of the graphite, right? Just a minute, right? Graphite. Yes, this is graphite. This is graphite, right? Now diamond. Yes, what is diamond? What is diamond? Yes.
Sir,
What is diamond?
it's also a structure made up of layers or giant of covalent bonds, many
Hmm.
strong covalent bonds.
Hmm. But the diamond is the hardest known material in the world, right? So point number one is hardest known material. Hardest known material. Number two, it has giant molecular structure. It has giant molecular structure. It is allotropic form of carbon. It is allotropic form of carbon. Each carbon atom is attached with other carbon with other carbon by covalent bonding. By covalent bonding. By covalent bonding. Now the structure of diamond. Now the structure of diamond. Now look at the structure of diamond. This is carbon. So this carbon, here we have another carbon. This is the structure of diamond. Yes, each atom is. Are you getting my point or not?
So diamond also has hexagonal structure.
Yes, it also has hexagonal structure. Now I am going to teach you how to draw, right? In the first step, this is 1, 2, 3, and 4. 1, 2, 3, 4, 5. This is first step, right? In the second step, three bonds are formed. This is first one. This is second form. This is third. Then in the next step, in the next step, hmm, this bond is attached with these are attached. These two are also attached. Then make this one, make this one, make this one. This is the structure, right? I think this one is better than other. So no need to draw this structure, right? So this is diamond. This is diamond. Now point number 5. Number 5. It has hexagonal structure. It has hexagonal structure. Diamond has hexagonal structure. So this is covalent bonding. This is covalent bonding. This is carbon atom. So can you tell me how many covalent bonds are there? Each covalent, each carbon atom has can form how many bonds?
3, sir.
Are you sure? 3? This is 1, this is 2, this is 3, this is 4. So point number 6 is each carbon atom can form 4 bonds. Each carbon atom
Diamond
can
doesn't
form.
conduct electricity.
Yes, that's why, and there is no free electron. Number 7. That's why there will be no free electron. There will be no free electron. Diamond is
Sir,
yes, not a good conductor.
so basically, you can say carbon has 4 valence electrons, so it can
Mhm.
form 4 bonds here. So, but in
Mhm.
diamond, each carbon atom uses 4 valence electrons, all of its
Mhm.
polar valence electrons, to form covalent.
It can form. It forms 4 bonds.
Okay.
That's why there will be no free electrons. Number 8, diamond is not a good conductor. Because it does not have free electrons. That's why there will be no free electrons. So diamond is not a good conductor because it does not have free electrons. Now next is can you tell me the melting point? This
Sir,
structure,
very high.
sorry,
The melting point would be very high.
melting point is very high. Same reason. Point number 8. Diamond structure is tetrahedron. Diamond structure is tetrahedron because it forms 4 bonds. Because it has 4 bonds. So diamond has high melting point.
Sir, shouldn't now there would be a point of slippery, if it is slippery or not.
No, it is the hardest material. Why? Because throughout the structure we have covalent bonding. So number 9,
I meant the slipperiness.
there is no slipperiness because we cannot drag any layer of the
Okay.
diamond easily. Insoluble in water, insoluble in water, hardest material, hardest non-material. So last is silicon dioxide, SiO2. Silicon dioxide, SiO2. Before going to silicon, yes, yes.
Uh, why was the graphite insoluble? Why is graphite and diamond insoluble in water?
Because water require those elements which have negative charge or positive charge, right? So there is no positive or negative charge in the carbon, in the graphite as well as in the diamond. No charge.
Uh, but then you say graphite doesn't it have is a good conductor?
Yes, graphite is a good conductor of.
It has a negative charge. So when you
No, it has no charge. It has no charge. It has no charge.
okay.
Graphite is neutral. If it has any charge, it will dissolve in water.
Here in diamond it is insoluble in water. But what about organic solvent?
Same insoluble in inorganic solvent. Inorganic solvent. Insoluble.
Okay.
So diamond does not conduct electricity. It has number 11. It has high melting point. Diamond has high melting point. Why? Because of giant molecular structure. It has strong covalent bonding throughout the structure. Covalent bonding throughout the structure. It has strong covalent bonding throughout the structure. So diamond is the hardest as we have discussed. So how many bonds? 4 bonds. So no free electrons. We have discussed.
Sir.
Yes.
Diamonds are not slippery because they don't because they have a strong forces of
Because there is no
nature.
intermolecular force of attraction between the layers.
Okay, so it
Rightly?
has no intermolecular
It
attraction.
has exactly. There is no intermolecular. There is no van der Waal.
So what type of force of attraction it has?
Throughout the structure, covalent bonding throughout the structure. As we all know that covalent bonding is the strongest one, right? So a lot of temperature is required to overcome this covalent bonding attraction to melt, right? That's why it has the highest, or we can say that high melting point, right? Now, uses of,
Sir,
yes.
so basically, diamond doesn't have a layer structure.
It doesn't have any layer structure.
Okay, sir.
Whenever you have van der Waals forces, it means you have layer structure. Whenever you have the van der Waals, it means you have the layer structure. Now, you know that in heavy drills, in heavy drill bits and tooling equipment, in heavy drill bits and tooling equipment, diamond is used.
Sir,
Excuse me, just a minute, right? We know that diamond cuts diamond, right? Diamond cuts diamond because it is the hardest known material. Yes, ask me your question.
yes, sir. So I was asking, so covalent bonding is stronger or ionic bonding?
Ionic bonding is the strongest bonding, but covalent bond is not such a weaker bond. It is weaker than ionic bond, but it is much stronger than other bonds.
Okay.
So next is diamond is used in industry, or you can say that diamond is used in jewelry. Diamond is used in jewelry due to sparkly appearance. Yes, any question regarding uses of diamond and graphite?
And sir, graphite is used in like pencils.
Yes, graphite is used in pencil. So point number next is graphite is used in pencils. It is used in lubricant. Used as lubricant. You know that oil is sometimes it is very expensive and it's not functioning as the graphite, right? You know that graphite has slippery touch, so we can use as lubricant. Graphite is also used to make electrode. graphite is also used electrode, inert electrode, inner
what is that?
electrode. Sorry,
What is electrode?
you know that electroplating, right? If you have a golden watch, so gold is plated on a metal, right? So electrode is sort of metal which is used for plating, right? So we will discuss later in the redox chapter.
Okay, sir.
So in electrolysis, electrode is used, right? A metal rod dipped in electrolyte is called electrode. So this is the uses of graphite and diamond. Now next is silicon 4 oxide. Or silicon dioxide. Silicon 4 oxide. Now look at the structure of the silicon dioxide. This is
Sir, what is
silicon.
silicon oxide?
Sorry,
What is silicon oxide?
silicon oxide and silicon dioxide or silicon 4 oxide all are same. SiO2 is the formula of silicon 4 oxide. Now look at the structure of silicon. So molecular formula is Si2O4. Si2O4. Are you getting my point or not?
Yes, sir.
Yes, sir.
SiO2 is empirical formula, Si2O4 is molecular formula. So each silicon atom is tetrahedrally joined. One, two, three, four. Each silicon atom is tetrahedrally joined. Okay. So in the next class, we will start silicon 4 oxide, I think. Do you have any question?
No, sir.
Yes.
Sir,
Yes,
what do you
yes.
mean W1234? It has 4 bonds.
You are asking about this one, 1, 2, 3, 4. So it means silicon has that tetrahedral structure because it formed 4 bonds.
Okay.
Any question?
No, sir.
Okay. So inshallah, in the next class, we will discuss remaining part of the chapter, right? Take care. Allah Hafiz.
Thank you, sir. Allah Hafiz.
Allah Hafiz, bete.
Thank you, sir. Allah Hafiz.
Allah Hafiz.